Every time an email is sent, a purchase is made, or a demographic survey is filled out, another data point is logged. Modern businesses are sitting on billions of these raw, unorganized entries. But raw information on a server is useless on its own. Without a mechanism to sort through the noise, a business has no way to find the underlying patterns or anticipate future outcomes. The challenge is that computers do not learn the way human beings do. They cannot glance at a spreadsheet and intuit a trend. They require highly specific mathematical environments to translate raw numbers into actual insight. To solve this, data scientists route raw information through two distinct training pipelines. Data can be sent down a strict linear path with heavy guidance, or into an expansive exploratory web left to its own devices. These two frameworks represent the basic logic used to translate raw information into digital intelligence. The first of these methods is supervised learning. It operates exactly like a student learning a subject from a teacher who holds a complete, flawless answer key. The core mechanism is labeled data. Every input is explicitly paired with its correct output. For a spam filter, you feed the model phrases like "win money now," mapped to spam, and routine phrases like "meeting at 10 a.m." to not spam. By processing thousands of these pre-sorted examples, the model learns the mathematical relationship between specific vocabulary and junk mail. This makes the model highly accurate at predicting the correct result the moment a brand new, unseen email arrives in your inbox. The drawback is the setup. The entire system relies on humans doing the tedious manual work of providing millions of labeled examples beforehand. Supervised learning is an effective tool when a business needs a specific, repeatable prediction and has the human resources to provide the initial training data. The second approach is unsupervised learning. Instead of relying on a human instructor, the model learns by independently discovering patterns in the data. Here, the primary input is unlabeled data. Looking at this cloud, we see raw information completely devoid of an answer key or predefined categories. Consider customer segmentation. A company might have vast records of user ages, locations, and spending habits, but no existing labels that tag anyone as a budget or rich customer. When fed into an unsupervised model, the system autonomously analyzes that raw information and groups the data points into distinct clusters based on hidden similarities. Because it does not require human labeling, it can scale instantly and discover structural patterns that analysts might have overlooked. The trade-off is ambiguity. The model does not provide definitive right or wrong answers. It simply groups the data, leaving humans to interpret what those newly formed clusters actually represent. Unsupervised learning organizes unknown chaos into structured groups, revealing hidden relationships within a dataset. Looking at this split screen, the distinction is clear. Supervised learning yields specific predictions. Unsupervised learning yields hidden structures. Most businesses combine these two distinct frameworks into a single workflow. First, unsupervised learning independently maps out defined target groups from a massive customer base. Once structured, the business applies supervised learning to calculate which products those specific segments are most likely to buy next. In the real world, practical machine learning relies on the combined application of guided prediction and independent discovery. Knowing when to deploy the teacher and when to unleash the explorer allows a business to organize its data and anticipate what comes next.